All right, good morning, everyone, or at least good morning from us. I realize it's not morning for probably most of the world. Can everybody hear us okay?
I can.
Awesome. Awesome. Thanks, everybody, for joining us this morning. We've got some great demos that are queued up for today, which I'm excited about. Before we jump into those, is there anyone that's new to the call that would like to say hi? I'm especially intrigued by the North Hills. Like, we have an entire room in, which is awesome. Yeah, I'm gonna make you get up and unmute, sorry.
Yeah, we don't have remote controls on that. We're actually at Uber ATG in Pittsburgh. Got a stack of people here. I'm George. I work on Basil's build farm. Anthony works on build team with me. Justin works on stuff, I'm not sure what, and Anthony Guardaro also works on something. Just wanted to say hi and joined the list earlier this week.
Yeah, awesome. Thanks for joining. I love that you're getting some conference rooms in. That's awesome.
Go Stillers.
Hi, my name's Colin. Yeah, I'm calling in from Redmond. I work at Microsoft, and we're using gRPC for some of our Azure machine learning stuff. So I'm really excited to get a chance to hear about observability and stuff.
Awesome. Thanks for joining, Colin.
So hello all from my side. I'm Benjamin. I'm from Germany, working at Heinrich, a forklift company in Germany. And right now I'm mostly working with gRPC, Proto buffers, and also working on the Jaeger and open tracing stuff.
Great. Thanks for joining us. All right. Well, if no one else has anything they'd like to add, then we can jump into Dimitri introducing himself.
Cool, thanks, April. Cool, so I'm Dimitri. I work for WSO2. It's an open source, and I'm sort of in charge of our cloud efforts, but I also participate in the Ballerina programming language efforts. And within Ballerina, I'm sort of in charge of the ecosystem and our integrations with other technologies. And we'll also, from that same team, we'll have Danesh, who is actually leading our gRPC efforts. So I think what we will do is I'll give like maybe a 5-minute demo of Ballerina in general, just for those of you who have not used Ballerina yet. And then Danesh will, and my demo will be not related to gRPC, sort of just intro to the language. And then Danesh, since he is our gRPC guy, he'll share his screen and he'll show the gRPC specific part. Let me share my screen. Okay, so you should be able to see my screen now. And since we have people from Microsoft on the call, I'll be using VS Code for the demo. But obviously we have plugins for the IDEs as well. So I'll just do like a quick hello world thing for you to get a feel of Ballerina. And I'll just do whatever hello world service. So Ballerina is the language that has been designed for microservices. So it has all the native constructs for like services, endpoints, and type safety, even for HTTP and REST interfaces. I'll just do here's a service that I've added. I'll define a resource for sort of my hello world. I'll do an HTTP response. I'll, I guess, set some payload. And I'll send it back. So that's sort of a feel of how Ballerina works in general, right? So that would be, and it's type safe, so it would tell me if I'm not assigning to a variable, if the variable is there, or if types don't match, and so on. I'll just ignore this one. So again, native constructs of services. If I want to add an endpoint to which I want to bind it, again, I can easily just define my endpoint and bind to it. So that's sort of the simplest hello world thing. If I want to make it, but like I can use annotations to further customize it. So if I want to, for example, say change the path from hello to some say base path, I could easily add an annotation for that. Say I want base path to be just the root. And obviously it has all the, like I could be adding annotations for things like security, like the scopes and so on. Path, root, methods, post. So very, very easy, very natural. All the annotations are kind of specific to the domain. They're not some auxiliary stuff. And again, everything is type safe. And so I can get, as you can see, I'm getting code completion for everything. So if I want for this post, if I want to get something from the request, I can say, I want the string, payload, request, and just get text from it. And again, the text if the types are incompatible. So this one can be a string, its union type can be a string, can be an error. I could probably just do a match and provide different, like I could do say var, and I could say that I want to match that. And say if it's a string, then assign it to something. If it's an error, assign it to something else. Or I could just say, just ignore the error. If there's an error, just push it up the calling stack. That's the check keyword. Oops. So that's sort of the general feeling of the language. And obviously I can run it, or I can just build it. So we're going to run demo.val. The nice thing, and if I do that, I can now go ahead and curl into it. Curl localhost. See what I did there, 1990. I wish I did a post. So I would do post. Localhost 1990. Yeah. And the nice thing is that since it's cloud native, it has integration with all the things like Docker and Kubernetes and so on. So right now I just compiled it and run it locally and as executable, but I could add Docker or actually let's do Kubernetes. And I could add some annotations, which I will just copy and paste from my demo so I don't have to do the typing. So I could say, like for that listener, that port, I want to do it. I want that to be turned into node port in Kubernetes. And for that service, again, I want to just get a deployment with a Docker image generated. And there's obviously a bunch of other things that I could do, like scaling, ingress, and so on. And if I do that, then if I do my ballerina build demo.val, then this time, instead of generating the executable, it would generate the artifacts. Like that, it would start going through the build process. Once it detects that there are those annotations coming from Kubernetes package, it will let the package do the generation, and in that case, it will generate the YAMLs for the service and for the or like for the node-pod service and then for the deployment. And here is doing that. Yeah. So now if I do tree, you will see that actually generated all the YAMLs and the Docker file. And now to deploy that, I simply can do kube control and use those YAMLs. So that's sort of like a really quick intro to Ballerina, and there's obviously a lot more to it. Like if you go to Ballerina website, to the examples, then you'll see there's just a lot built in. There's native support for different protocols, different types, event streams, WebSockets, circuit breaking, load balancing, and so on. And so specifically for gRPC, Danish actually is heading the efforts, and he has implemented, and his team, some pretty cool stuff, including the ability to generate gRPC interface from code as opposed to having to go from definition to code. So I think I'll pass control to Danish.
Shall I take that? Okay.
Yes.
So thank you, Dimitri. Hope you can see my ID, IntelliJ IDEA. So in my demonstration, I will quickly demonstrate the unary service sample, how the unary gRPC unary service create in Ballerina, and how it is connected with the blocking client. So I already created a Ballerina gRPC project, Ballerina. So we have I already created the service as well to make it easier. So I'll go through the code and explain how we create the service. So as Dimitri explained, we need to create an endpoint. So endpoint, I will give the port to 9090 and the host to localhost. And we have the listener endpoint here. So once you define the endpoint, we need to bind it to our service. I create a service called Hello World and bind it to my predefined endpoint. So after that, we need to create the service methods. So I created one method called hello, and we have two parameters here. One is the call endpoint, which we use to send the response back to the caller. So this is similar to the Java implementation. In Java, we have the stream observer. So we are passing to the method, and we are using that one to send the response back to the client. So the same thing here as well. So we are creating and passing an endpoint, and the next parameter is the request message. Here I create a simple message. So in Ballerina, the message is called a record type. So inside the record type, we can create the fields we need to send. So the same like the Proto definition. So the difference between the Proto definition and the types we are defining here is like we are not defining an index for the field. So those index are the order order which we define the fields. That will take in as the field index of that. So I will show that one later. So so here in this function, we have the request message called hello request, which have the one field called name, string type. So here what I'm doing is like I'm constructing the response, hello response from the request we get. So here in this line, I'm constructing that. So once I constructed that, we can use the call endpoint to send the response back to the client. So here also we can get an error, or we can have a successfully send it. If it is successfully transmitted, it will not get an error. We will get an empty response. So I'm printing that error. If there is an error, we are printing that. If it is not, I'm printing the response we are sending back to the client. So this but statement is used like for if it is an empty response. If I'm get the empty, we have not get an error. Do something else. So like in the Java, we need to end the stream. So we have another method called complete. So end the stream in the server side so that the client can get the message, read the response message. So here are the message types. So let's build the service first. So for the building, we are using Ballerina build. So my service is inside the service package. So in Ballerina, we are not specifying the package inside the source code. Once the source file is in a folder directly, that directory considers as the package. So I will build a package now. So I'm executing the command build the Ballerina build service. Once we build that, so you will see a target directory inside our project. There you can see there's a ballex file is created. That ballex file is the build artifact of the Ballerina. Addition to that, we are generating the Proto file from the service itself. So that's a bit different from the other languages. The other languages create the Proto file contract first and generate the source code for that. In Ballerina, we are using the other way around. We are using the code first approach, where we create the service, and from that service, we will generate the service contract. So we need to use this contract to generate the client stub as well. So I will show you that. So let's start the service first. So to start the service, we will run the artifact we generated. So we are executing the command Ballerina run service ballex file. So if we run that, okay, seems like okay. So if you run the service, you will get the message saying like the service is deployed successfully for the 1990 port. Okay, let's go to the service now. Now we are deploying the client correctly, the service correctly. Now let's go to the client side. For the client side, we need to generate the stub first, client stub from the Proto file. So we have the Proto file already. So we have another tool in Ballerina distribution to generate the client stubs. So for that, we need to execute Ballerina gRPC -- input. For the input, we need to give the Proto input, Proto file. And for the output, we need to specify the directly which we need to save those stub files. So I will give the client directory. So if you run that, so it will download the Proto C executor and then generate the files. So now it's generated. Let's go and see the client code. So you can see there's a client stub generated. so we are using that client stub to connect to the service. So let's create the code. So I will give the input name as Sam, and here we are defined the endpoint already, so we can use the endpoint here and connected to our hello method. So they are listed here. We have the hello method. For that we can send our request, and from this it will return a union type. It can be either error or the response we are getting from the service. So we will create a union response, and we need to match it to get the exact response. So I will do that one now. Match union response. So here we have hello response. Payload.
Looks like Ryan had a question about, does Ballerina implement gRPC interceptors?
Yeah.
So not yet. That's still in the works. So since it's an open source project, everyone's welcome to contribute. Interceptors are not yet there.
Yeah, the gRPC implementation is in the initial state, so we are actually developing that one. Yeah. So we have the match statement now, so we can let's print the message we
Oh yeah, go ahead, we're unmuted.
Hey, can I interrupt you briefly? I have a question.
Yeah.
Stepping back a minute or two, I saw that you defined a type that turned into a proto.
Yeah. Here, this one, right?
But the tag numbers aren't in there. So does the proto get regenerated every time you modify that type?
This type, right?
Yeah.
Yeah. Yes. So if you yes. So if we.
So what happens if you remove a type? How do you maintain the backwards compatibility of proto?
Yeah. If you create this, if you modify the type, means you are adding a new fields to that type, or we are removing one field, or whatever, right? So
yeah.
So if you create another, let's say intage here, so it will create another field here. Let's say in 32 age, and get the index value to 2. So that field order, the field order is the one we get the index for this.
And if you removed the field name, what proto would it generate?
So then it will be like this. So so the service developer should be should have the responsibility to maintain that backward compatibility. So if we register another service without the name, that means it's a new service. It's a new service. So the client who client who already connect to that the previous service will not be able to connect to the new service. The message which are coming, it not be serialized.
This proto is automatically generated from the type you wrote, correct? Would you mind showing
Yes.
what it auto-generates?
Sorry, I didn't get your name.
Would you mind automatically generating it?
Yes. So, do you need to generate again?
Yeah.
If you could regenerate it again, that would be great.
Okay, yeah. So
The reason I ask is because Protobuf provides this backwards compatibility when you add and remove fields. Like, that's what the tag number provides. It allows you to modify the service in a backwards compatible way. If you lose the field numbers, then you lose that backwards compatibility.
yeah, if you want to add a new fields, that means you need get a new field number.
Is there a way of specifying the field numbers in the ballerina file?
No, currently we are not allowing. So we are going to do that. So we can in Protobuf we can reserve the numbers so that it will at that way it will. What I understand is, like, in Proto definition they have a reserve numbers so that it will ensure the backward compatibility. So in this implementation we doesn't have that. So what?
Okay. I didn't want to dwell too much on it. I was just curious.
Well, so excuse me. In the interest of time, because we're running out of time for this part of the meeting, do you want to kind of quickly highlight, the features that you're working on with the gRPC implementation? Is there anything that you're needing from the larger community?
Yes, currently we are implementing from we have developed the main types for streaming and all. So I shall I continue with the demonstration or?
No,
Well, we've got another demo that we need to get to.
Danish, could you just show the page ballerina by example to just show what is implemented already and just tell what's in the works, and also if there's any help that this community can provide, just say that as well, and sort of wrap it up with that.
Yeah.
Just
so,
mention what's there, what's in the works, what kind of help you need.
Yeah. Currently the state of we have these different types. We are defining different types of types. So we have the service listening, streaming, client streaming, bidirectional streaming, and all. And currently doesn't support the interceptors timeout feature here. So we are currently doing that. So if you go to the so I need some suggestions from you as well. So here in the non-unary non-blocking scenario, what we have done is, like, we create a listener in the client side. This is the client code. The client side, we register listener to get the response back. So if you go to the server streaming part, the server streaming is like the service sends multiple messages, and the client will listen to that. So that's what we have right now. So we are improving that to make all the features right now in gRPC. So
awesome. Well, thank you very much, both you and Dimitri, for showing this. And then we've got, I know Dimitri put some links in the working doc as well, so if folks want to check it out more and dive more into the language and the implementations, and also there's the links there for giving feedback and getting involved as well. So thank you very much for that.
yeah, thank you.
And Benjamin, we're up next with your open tracing.
Yes. Just start sharing.
Yes, I stopped.
Okay. I think you should see my desktop right now.
We do.
Perfect. So I set up the Getting Started guide also on our GitHub repository together with the examples. So the example is basically the hello world from the gRPC repository, but I had to upgrade it because the C# gRPC example is pretty old. The gRPC repository, it's I think targeting the what is it, 1.8 or 0, yeah, 1.8, and interceptors were implemented with 1.10. So just keep in mind when you want to try the example, you should just check out this repository and not use the gRPC example that you already may have. So what we have here is basically the Hello World server that I hope most of you know, at least the people working with C#. So we have generated from the Protos these files. And then we're just generating a simple server. So this is not intercepted at all right now. This is just the hello world, just to show the progression. I will just go into the client and server. With .NET Run, you can run the project folder you're in. So with .NET Run in the greeter server, we should see that the server is started now. Using .NET Run is rebuilding the package, so it takes a couple of seconds. So nothing fancy here yet. It will get a bit more interesting if we add tracing. So for using tracing, we have to add some of the NuGet packages. I already installed it. The Getting Started guide will get you to this point. So basically, you will have to add the tracing framework itself, which is just the interfaces. So it's just the abstract. And for the tutorial, I was using the Jaeger client, which I also worked on. And what we also will use is the extension logging, just to get the internals logged to the console. So just to get it a bit shorter, I already copied this file for the tracing helper. This is basically setting up a tracer for a service name. This is basically setting up a tracer at the point where we init it for a specific service name with a logging factory. And right now we want to sample all the traces, not just probabilistic ones. We want a reporter that logs the spawns so that we see everything. And then we are using this configuration to generate everything. I'm just going over it quickly because there's a lot of documentation on it, and I linked it in the Getting Started. So just to keep the time. Okay, so we'll have a look at the server side first. So what we need right now is to generate this tracer. helper in a tracer. This needs a service name. I will just call it server. And we need a logging factory. We get a logger factory by using the new logger factory and add a provider to it. From the NuGet package, we get the add console. So we have a tracer right now, but we need to intercept our server. So this is where the gRPC tracing package is coming into place. This is tracing interceptor. There's a class called server tracing interceptor, which accepts a tracer. Luckily, we created one. And then to use it on the server side, we can just add an intercept call here. This was integrated with the 1.10 version in C#. So I just saved it. If we run the server again, we will already see that there's a lot of logging happening. We initialize the tracer. Yeah, it's just basically information about the tracing. So let's also add tracing to the client before we look into the tracing more. So it's basically pretty similar. We have to create the logging factory. Then we need a tracer. And then we need to generate a client interceptor. Okay, we have our client tracing interceptor, which is connected to the tracer. So where do we add it? It's connected to the channel. So basically we're saying we want to intercept the channel. I will just extract a variable. And what we will see is it doesn't create a new channel, but it's creating a call invoker. And a call invoker is basically a wrapper around a channel, adding some new logic. But you can use it everywhere where you would usually use a channel. So we have the server running. We have the client. So we should already be ready to see some traces. So for visualization, I'm just using the Jaeger UI. And there's a convenient all-in-one package, which already has some remote endpoint for the tracer and also included a web service for the UI. It's called Jaeger all-in-one. So the server, let's just run the server again. The client, just so that everything is logged to this endpoint, which started now. So we see that we created a spawn. So we made a call for a specific trace ID with a spawn ID. And we'll also see here that we received the same trace ID and we generated a new spawn ID, which has the spawn ID from the incoming call as a parent. So this is where the hierarchy is coming from. So let's just have a look at our Jaeger UI. So once you start a Docker container, it will create a web service at 16,686. And we can already see that we have 2 services recognized and tracked. I will just select the server. And then you can also filter on the gRPC operation. So on the service, this part is the service name, and the later part is the name of the service. I will just show all. You can also filter for tags, which I will get into in a second. You can also say just some calls that took a duration and also limited. So I'll just minimize the videos. So what we see here on the right is that we have a trace that took 178 milliseconds. If you have a lot of spawns and a lot of calls, you would see them all here. Just wait a second. Just create a second client call. Yeah. And you can either click on a point that interests you, or you could click on the detail. You see how many spawns are in this root spawn. You also see what services got how many calls. You can also go into dependencies to just show a graph of how many calls from which endpoint are generated. In the all-in-one demo, this is auto-generated. If you are doing a real Jaeger collector instance, you can just run this separately so that's not running always in the background. So just get into one of the detailed views. We see the client generate a call for hello world, our greeter service with the say hello. Greeter client, say hello. And we got the hello request. And usually this is not tracked. So if you don't add tags or logs, it's just you just see how long it took and get some process information. So we have the information what sampler was used to log this spawn, and also information about what was the endpoint where it came in. If we want to get some more information, you would have to let's just go to the server. I'll just copy it for the sake of the time. Okay, it looks like I've not in it anymore. There's also a variant where you can define tracing configuration, and you also give it a tracer name. So just place the class name. So if you want to have a bit more possibilities for configuration, you just need to use a configuration instead of the interceptor directly. Oh, sorry. Server tracing intercept configuration with the same tracer. And then we can just use the builder methods. So we can turn on the verbosity. There should be a builder. There's the builder. Just use the wrong class. And then you can say with verbosity true and build it. it's just with verbosity and the true is implicit. So we have now more in detailed. I just do the same here. Just use the builder with verbosity. Let's build it. Just rerun everything. So if I go back and let's show all the traces, we will see that we get a lot more logs. Like we can right now also see what was the proto that we got in with all the data being serialized. So let's just have a quick look at how to add tracing information on the server side in your implementation. So I have to get the tracer to here. So I will add it to the implementation's constructor. An iTracer. And now I can use the tracer to build a new spawn. There's the build spawn method. I could say hello meeting, and then start it as active. This does not give me a spawn, but a scope. And I can use it by using the using statement. So while I am in the scope, everything is logged to that specific scope. So all this code has a separate spawn in the output. And if I go to scope spawn, I can get the active spawn and, for example, add text to it or add logs. So, for example, I add log hello world and I set a tags. And I say the component is test. So if I run the server again, and update here, we'll see what I will just make it a bit bigger. We will see that we have a new spawn here, the hello meeting spawn that we created here. And since I added the log and the tag to this active spawn in this place, they will be set here. So we have all the tags here and we have our hello world here. And the auto-generated ones were part of the upper spawn, so they will still be here. And if you look here, all those timestamps are absolute to the starting time. So basically it was in between here in between the request and response, and we see it here by the timing. That's basically it. So if you have any questions.
Thanks very much for the demo.
Welcome.
And I think we've got the links in the working doc to the
to the demo and to the project
files. Yeah. So folks can play with it more. Anybody have any questions or anything?
So this is using the C# interceptor APIs?
Yeah. which was added in 1.10. Yeah.
And so Open Census is hooking the gRPC core directly, right?
It hooks to the gRPC core directly, yeah.
So why the difference, I guess, for the different implementations?
What implementations for this urban decline interceptor, or?
So Open Census and Open Tracing kind of have the same goal in mind, but it seems like they're implemented in really different ways.
Yeah, right now there is no C# implementation of Open Census, and I already did the Open Tracing stuff in January or so. Yeah. So it's just there because we were faster with the Jaeger implementation.
Gotcha.
Yeah. But Open Census will also have exporters for Jaeger, as far as I know. So you will also be able to use the Jaeger UI for viewing the traces, for example, if you like it more. And yeah.
All right, well, does anybody have any questions about gRPC overall, as we have just a few minutes left? Or anything anyone want to share, add?
So I basically have a question. Is there a roadmap or anything for getting the name resolver in C# done, or basically the CRS implementation done in C# or for Windows?
No, no, I don't think that we have. Okay, to be honest, like I don't think that it's on the roadmap. Obviously, like we want to get it done, but I don't think that we're specifically prioritizing it because we have not seen too much of our customer need to do that. So if you want that prioritized, just let us know, and as you have right now, just also like follow along the bug and just let us know that that's important.
Yeah, right now at our company, it's a pretty big showstopper because we are using Windows machines. So basically what we're doing is we have implemented a microservice-oriented architecture, which basically uses gRPC internally, and it can on one side it can run in the cloud and also on premise and also interact with each other. And so we need a way to get the name resolution. And so since we're running it in the IT infrastructure of the customer, we are not, we don't have the option to set up a DNS server or something. So yeah, CRS or name resolution would be great. And I know there are some GitHub issues already open, and I already did a implementation for the C++ variant where you could do DNS resolution, or at least use a gRPC load balancer in C++ directly without DNS, which would also resolve the problem, at least work around it. But the last status I had on December was that there are internal discussions on how to get the to get it done.
So would CRE support on Windows sort of help you along there?
Yeah, either CRS, because then we can use the CRS as endpoint and just give the service to this authority for name resolution, and then I could do my own implementation internally. So basically, I'm just emulating a gRPC LV endpoint and could talk to it directly, since I also do the DNS resolution internally in my application. But for this, I need a way to use an authority, which is not allowed right now.
Got it. So I think CRE support on Windows has been something that we have been tracking for a little while. So I'll just follow back up and see when it can land and try and find something.
Yeah,
on that.
right.
Thanks.
Yeah.
Is there a plan for C++ server interceptors?
BJ.
I was gonna say, good question. You should know all the answers there. We can follow up.
I'm gonna have to follow up because I know that there's been some discussion around it. If anyone else knows, please let me know. But but Vijay should be the right person to answer, and I'll ask Vijay.
Cool. All right. Well, thanks everyone for joining us today, and big thanks to the Ballerina team and also to Benjamin for doing the demos and sharing your work with us. If anybody's got any questions or anything else comes up, please do make a comment in the working doc. Otherwise, we'll see you again in 2 weeks. Thanks all. Bye.
Bye.
Thanks.